Good afternoon, girls. In the last few classes, I have covered about frequency modulation and the analysis of frequency modulation equation. Today, I'm going to discuss about how to generate frequency modulated waves using different devices. And in today's class, the topic is generation of FM waves. If you consider, already we have learnt about amplitude modulation and what are the different circuits used for generating amplitude modulated waves, like transistor AM modulator, diode detector, ratio detector, etc. Similarly, for generation of FM waves, there are many circuits and there are many devices which can directly generate FM waves, but some of them are complex, and the most widely used FM generators are Fm modulator, Vector diode modulator, and basic reactance modulator. In the last class, I have given just a brief description about circuits or the components used in the different circuits. But now I am discussing about FM modulator. In FM modulator, you have to consider only the function of RF oscillator and principles of inductor and capacitor. Whereas when you come to Vector diode FM generator, you have to know the full complete basics of a Vector diode. For basic reactance modulator, you have to know the basics of FET. So today I will cover FM modulator. For Vector diode modulator and for basic reactance modulator, you will understand the concept betterly if you get back to the functioning or working of Vector diode as well as FET, field effect transistor. So coming to circuit of FM modulator, you can see the clear picture of the circuit. You have two blocks for FM modulator. One is RF oscillator, that is radio frequency oscillator. The other block comprises of inductor and a capacitor. If you observe the figure keenly, the capacitor has two plates. One is fixed plate and the other one is the diaphragm. And the space or the distance between these two metal plates will act as a dielectric. And this complete arrangement is known as condenser microphone. Now, as you can see, one plate is fixed, the other plate is called as diaphragm, which will vibrate to the sound waves, and you can see the dotted lines along the diaphragm, which states that vibrations of diaphragm with respect to sound waves. And the first block contains RF oscillator. It can also be called as carrier frequency oscillator because the range of frequencies for both RF oscillator as well as carrier frequency oscillator are the same. This is about the circuit diagram of FM modulator. Now coming to next concept, next paragraph. The above figure shows the circuit diagram of FM modulator circuit, which is most widely used in generation of FM waves. This is widely used because of its simplicity and construction. You can easily say from the circuit, construction needs only three blocks. One is RF oscillator. RF oscillator you can design according to the filters which you have learnt in the previous classes. The other concept is nothing but one inductor and one capacitor, which are easy to connect or easy to handle, and they will not occupy much space. So FM generator, in FM waves generation, we will use FM modulator widely. In similarly, for generation of AM waves, we had used AM modulator widely. So the circuit consists of two blocks, as I told. One is RF oscillator or carrier frequency oscillator. Another one is inductor and capacitor network. We have you have already seen in the circuit how these components are basically connected. Now, the RF oscillator is also called as carrier frequency oscillator because the frequency range of both these circuits are almost same, and the circuit has a resonant frequency which adds an inductor and capacitor, where the capacitor acts as a tuning capacitor and inductor simply acts as a passage for DC components. Now we have to remember resonant frequency. Already we have learnt about this resonant frequency in two types of circuits. One is series resonant and one is parallel resonant. Whatever may be the resonant circuit, the concept of resonance is concept of resonance occur whenever natural frequencies or fundamental frequencies of both the components get equal. Now in this case, the fundamental frequency of capacitor, the fundamental frequency of inductor, when these both match, a booming sound, or simply the phenomenon of resonance occurs, and that particular frequency is called as resonant frequency. Now the circuit is already designed so that it has a particular resonant frequency, and along with that it adds an inductor and a capacitor, where the capacitor acts as a tuning capacitor. Why it is called as tuning capacitor means, whenever you select certain frequency from RF oscillator block, now the inductor and the capacitor, both as a circuit combinedly, should accept the frequency which is generated by RF oscillator. After accepting the frequency, what should happen? The mic, as the second block acts as my condenser microphone, the sound waves have to respond for this frequencies. That tuning is done by this capacitor. That's why it is called as tuning capacitor. In simple words, tuning is nothing but whatever frequency which is generated through RF oscillator has to match with this condenser microphone. This matching is nothing but tuning. The tuning capacitor has two plates. One is fixed, the other is the diaphragm. The diaphragm vibrates in response to the sound waves. In this case, sound waves in the sense the frequency levels generated or sent by the RF oscillator. When sound waves are applied to the condenser microphone, the diaphragm, what will the diaphragm do? It will move front and back, to and fro, as shown by the dotted lines. You can see a circle made by the dotted lines that indicates that diaphragm is vibrating, and out of the microphone you can see the waves. Those are nothing but sound waves, or you can simply say as FM waves. This changes now the vibrations of the diaphragm will change the capacity of the capacitor. If the capacity of the capacitor is changed, then frequency will also change, because always F is equal to 1 by 2 pi into LC or RC. We have learned, or we have derived this expression for resonant frequency in the basic circuits in the previous classes. Now, this deviation in frequency of oscillator depends upon rate of the sound waves, and it does not affect the amplitude of oscillation. We have learned in the basics that in the frequency modulation process, other than frequency, that is amplitude and phase, will remain constant. That's why in this point he is telling that the deviation in the frequency depends upon rate of sound waves, but it does not affect the amplitude of oscillation, and thus FM waves will be generated from this circuit. Now, in the starting class, in the previous video class, I have missed explaining when and where the peaks of FM waves are like at which point they are closely packed, at which point they are loosely packed. Here in this figure you can see three samples. One is carrier wave, one is audio signal, the third one is frequency. Now, if you observe, carrier wave frequency is same, but FM wave has a differences in frequency. Once you observe, what is the process of modulation? Modulation is the process where either amplitude or frequency or phase of an audio signal is changed with respect to carrier wave. Now, in this case, in FM case, if you consider the audio signal amplitude, if you consider the audio signal with respect to amplitude of carrier wave, whenever the audio signal is rising from 0 to some constant level, at that point the cycles are loosely packed. Whenever it is coming down from the maximum value to this constant value, at that place peaks are closely packed. Whenever it is decreasing its amplitude in the negative direction, cycles are more loosely spaced than the previous one. Try to understand my concept. Amplitude is not changed in FM, only cycles of the frequency are either closely spaced or overlapped, it looks like overlap, or they are more openly spaced than the previous one. With respect to the audio signal, consider from 0 point, consider this black line in between as a average line. Say suppose it may be an average line. Now, whenever the audio signal is rising from 0 to maximum level in the positive direction, At that moment, the frequencies, the cycles of FM will be loosely packed, and the distance will be very, very less. Whenever the audio signal is falling from maximum value to 0, the cycles are closely packed. You can observe the difference. Whenever it's falling on the negative phase, what happens? The cycles of the frequency will be more loosely packed as compared to the positive phase. Now, a simple clue: wherever you find the constant value, ekkadaithe 0 ki audio signal padipotundo, at that point you can see cycles are closely packed. In the negative phases, cycles are more loosely packed. In the positive phases, cycles are little bit closely packed. This is the variation of frequency in FM wave. In this case, amplitude of neither the carrier nor the audio nor the FM wave are changed. Only frequencies are changed. That change in frequency you can see in three different cases. One is when the cycles are closely packed. The other point, when the cycles are overlapped, like very, very closely packed. Third one, when the cycles are loosely packed as compared to the positive phase. You can observe the same difference in this figure also. First one will represent audio signal, that means a simple AC signal which has to be modulated. The second wave shows AM wave. Amplitude of the wave is differing. And the third one is FM. In this case, you can clearly observe cycles are loosely packed, closely packed, more loosely packed. They will repeat continuously. This is the difference between AM and FM. But the common point is, we will consider a audio signal itself or the sine wave itself for the process of modulation, and in order to transmit our signal over longer distances, you will use a carrier wave which has a highest frequency as compared to this audio signal. Now, carrier signal will always be used only as a reference to either change the amplitude or frequency, but carrier doesn't have any kind of usage in both of the modulation procedures. If the third kind of modulation is phase modulation, but as of now you do not have that. Once again, you revise this PPT from first to last. Then please get back to your notebooks and refer the concept once. Very soon I will upload another video class for basic reactance modulator and varactor diode modulator. For those two, to understand those two concepts betterly, first you read about varactor diode and second upon you read about FET. Thank you, girls.